Hi and welcome back to Module 8, and today we are looking at video number 11, testing for cations. So in class we had a look at some different experiments that we could use to test whether a precipitate or not had occurred, and this is one of the ways that we can actually test for the presence of cations. So our precipitation reactions are again another form of a qualitative assessment or analysis for the presence of ions, but not a quantitative method. So our outcome that we're going to be looking at is conducting qualitative investigations. As we just said, we've already done flame tests, and our experiment that we did in class was involving precipitation and complexation reactions there to test for the presence of these ions. So you need to be able to know the various tests, again using your solubility rules, to be able to test for barium, calcium, magnesium, lead, silver, copper 2 and iron 2 and iron 3. So what we are going to look at, if we don't know what solution's present, so if we know or we are testing for a certain substance, so for example we're looking for the presence of copper, we will know what reactions that we can perform. But if we don't actually know what's present, we usually will use a flowchart. And a flowchart, it helps us take a more sequential approach to finding out which ion is actually present. So for this outcome, we're only looking at the cation, we're only looking at detecting the metal that is present. So while knowing a flowchart will also help you, knowing your solubility rules and also those precipitation and complexation reactions will certainly help as well. So the metals that we're looking at, we've got our barium. So when we look at barium, we have got that yellow-green flame. That yellow-green flame is going to be fairly indicative that the barium has been found and is present in that solution. Now, it's also going to, when we react something like, for example, barium chloride, which is what you use today, with some a sulfate anion, so a sodium sulfate, we're going to get a white precipitate form. Now, we can't use a complexation reaction for barium. It's not a transition metal. And when we've looked at our complexation reactions, of course, our transition metals are the ones that form those complex ions with the ligand. So moving on then to calcium, we've got a red flame, a white precipitate again with our sulfate. And again, it's not a transition element. So again, complexation can't be used there. Looking at magnesium, again, no complexation reactions. It doesn't have a distinct colour with a flame test, so we can't even use a flame test really. So we're looking really at our precipitation reactions where we get a white precipitate with our sulfate there as well. Going through looking at lead, we don't do a flame test with lead because of the toxic nature of lead. So again, that's not going to help us there at all. It's going to also have no complexation reactions, so that's no use. So we're just going to use our white precipitate that it'll form with the chloride ions, and you would have noticed that there was also a yellow precipitate with the iodide ions. So they're really our only tests for our lead. And looking then at silver, again, no distinct colour there. It does form a complex, and you would have hopefully seen that in our tests. And it forms a white precipitate with chloride, so not so many tests there for that one. Copper, blue-green flame, forms a blue precipitate with our hydroxide, and again it does have a complexation reaction with our ammonia and water. Then we've got our copper ions, so again, our iron ions, so no distinct colour. It's, remember copper, iron 2 has our green precipitate, whereas our copper 3, I keep saying copper, our iron 3 has a browny coloured precipitate there, which is that real difference. And our iron 2 actually forms a complexation reaction there with giving that blood red with our thiocyanate ion, which again you tested in your experiment today. So let's have a look, and this is what we're going to work on in class together. You can see here, and again I'll just pop me out, You can see here a fairly complex flowchart. So if we've got an unknown cation, this one will take us through, say, adding chloride ions. In this case, we're usually adding hydrochloric acid. If we get a precipitate, it's likely to either be silver chloride, as per what we just talked about, and lead chloride. And then we can go down through here, exposure to light. Remember, when we get silver, usually it forms a darker kind of color when we are exposed to light, and we can then test it with some further testing. Here, again, exposure to light, if we don't have a change, we can add some hydroxide there and get the white precipitate, or we can add some potassium iodide there and get the yellow. If we don't, we can filter out our precipitate and take our filtrate, our remainder, and again do our further tests and come down here. This one is another person's rough guide to a flowchart, and you'll see that there's a lot of similarities, but the way they've set it out is a little bit different, a little bit more like our dichotomous key. We've got our list of unknown cations there, and I do like that, so that we have that there and at the forefront, so we can see, again, adding our chloride ions. Does it have a precipitate? No precipitate, very much like the dichotomous key. Okay, so we've got the white precipitate. What do we notice? It darkens to form, or it doesn't dissolve. Here, if we add some sulfate, what will it form? Add hydroxide, and then looking at our different colors. So I do quite like that one there. Looking here, this one has come out of your textbook, very similar to the first one that we did have, but with the other one had the complexation reactions there, which I think is important to add, because that's what we're looking at for confirmation of what ion. This one's out of our Nelson textbook. Now this one's quite different, and this is where we need to work out what works well for you. This one starts with adding our drops of sodium hydroxide. So they've used it straight up to remove some other components there. So sodium hydroxide, if you get a coloured precipitate, what could it be? Then, and you'll notice down here, that's when they're adding their chloride ions. If it's no precipitate, this is what it'll be. So there's no right or wrong way to do this. It's really working together with our understanding of the ions in which precipitates will form, and then bring it into a form that we understand. Of course, understanding the precipitation reactions behind it is important. This one here is another one courtesy of Conquer HSC. Again, this one starts without adding HCl, no precipitate formed. I find this one a little bit more complex, and certainly I think something a little bit more simpler will work. Here we can filter it. If we get no precipitate form, we'll add some more here. Here we're adding more, and so on. So in class, what we're going to do is we're going to work together using all of these. I've got some laminated copies. We're going to lay them around, and we're going to individually work out which way works well for us. See you then.